Hey everybody, welcome to our webinar today, How to Compare Heat Pump Quotes. I'm Joe Wachunas with Electrify Now, here as always with my teammate Brian Stewart. We'll introduce our three great panelists in just a second. Today's webinar is being brought to you by Electrify Now, an all-volunteer organization that promotes electrification as the quickest path to decarbonization and, more importantly, something that we can all take an active part in achieving. Along with, it's brought to you by the Learn program, a San Diego-based workforce education and training program that's partnered with us at Electrify Now to offer these free energy efficiency and electrification webinars. Please visit their website for more information, san-diego-learn.com. And one other shout out, this webinar is also part of Heat Pump Week. All week long, last week and stretching into a little bit of this week as part of Earth Day and Earth Week, the Heat Pump Partnership has been organizing a lot of great events about heat pumps. That's heat pumps for space heating, water heating. We'll put a link in the chat. Check out some of their great events and resources, and excited to be part of it. Okay, so this webinar is part of our Go Electric series, where we're talking about how electrification brings lower energy bills for most households across the country, cleaner indoor air, cleaner outdoor air, more comfort, and increased safety, and thus reducing all types of pollution. And as I mentioned before, the Learn program has a ton of great resources. It's all free and open to the public. Three we just wanted to highlight really quickly are heat pump water heater best practices and job aids. Check out that QR code. The heat pump for every climate. Lots of different heat pumps, and there's lots of them for every climate. And then what homeowners need to know about heat pump water heaters, my favorite technology on the planet. All right, Brian, we're diving into heat pump quotes today. Why is this a subject of interest?
Yeah, well, thanks, Joe. And I think if anyone's gone through this process, you'll probably understand that it can be a little confusing, and it's for a lot of reasons. It's a somewhat complicated topic. There's no typically standard format that quotes that you will get from different contractors will provide for you. There's some terms that might be mysterious, and depending on the contractor you're working with, there will be varying levels of evaluation and information that they provide to you. So, I think what we're trying to do today is to help kind of make this less mysterious for people, make it possible for people to really understand what kinds of questions you should be asking to make sure that you get the right system for your home. And I think that, we don't want to make this seem more complicated than it needs to be, but I think if you're the kind of person that wants to be making informed decisions about the stuff that you're paying for, and this is a fairly expensive investment, then what we hope to do today is just make it easier for you to kind of know what you need to know in order to make a really informed decision. I know there's going to be some people out there who won't want to get into this level of detail. That's fine too. And very likely you're going to end up with you're going to end up with a system that works for you. But you do occasionally hear about people who are unhappy with what they got. Maybe their homes aren't comfortable, or their energy bills seem to be higher than they had expected. And what we're going to go through today should help you to avoid any of those kind of problems. Okay, so first of all, I think it's important to know that depending on where you live, your heat pump needs to do, different things. If you're in the South, what you would be called the cooling dominated areas, where mostly it's about air conditioning. And then if you're in the northern part of the country, heating becomes a really important thing, and your system is probably inclined towards heating, and cooling is less of a concern. And that's why we've got three different panelists with us that are representing three different areas: Los Angeles, Denver, and Portland, here where we are. And we'll go through this with the panelists and kind of ask them how these questions that we're asking to our contractor might be different depending on whether you're in a heating or cooling dominated space. Denver, interestingly, is kind of like almost the extremes of both heating and cooling. So they're a great example. But okay, let's just start with what you should expect the contractor to do. And we'll go over this again with our panelists, but I'm just going to top line some of this stuff so you have a little bit of an idea about what we're talking about. I mean, I think it starts with, that your contractor should be asking you questions about what sort of comfort issues you might have, whether you've got cold or hot areas in your home. But they also need to be doing a thorough evaluation of your home and understand how it's working, you know, so that includes inspecting insulation in the attic and the crawl spaces if you've got those, looking at the ducts. If you've got a home that's got ducts in it now, you're going to want to know how well those are working. Are they insulated well? Are they leaking, et cetera? Are they properly sized? They're going to check the windows to make sure that you've got good ceiling and doors. And this might unearth some issues that you want to fix, because a better insulated home, a better sealed home is going to be easier to keep warm and cool. They're going to want to know whether you've got enough power in your electrical panel to handle the additional loads that he might require. And then, you know, it's always good for them to just take a look at your existing system, so they know what you've got, so to make sure that because you want to end up with something that's working better, at least as good, but hopefully better than what you've got today. So you should expect them to be doing this. If they're not doing this, if they're not crawling around your home, that's a little bit of a red flag that they're not really doing diligence. And we'll talk more about that. But all that crawling around and collecting information also goes into what's called the load calculation. And this is basically a piece of software that contractors use to make sure that they're getting the right size and capacity of equipment into your home. So there's all sorts of factors that go into this. We won't go into a lot of detail on that, but including a lot of things we just mentioned. And it outputs some really important information, which is essentially in these green boxes here, you can see there's some assumptions made about, for your local area, what the design temperature should be. And we'll go into that more, but that is the temperature that, you know, the system has to be able to keep your home comfortable at those temperatures, which are going to be different all over the country. All right. We'll talk about that more in a minute. And then it's important to know how many BTUs your system has to put out at those design temperatures in order to keep your system, your home cool. So in this case, the design temperature, outdoor design temperature for summer is 87 and for winter is 29. And they're saying that we're going to be okay if your indoor temperature is 75 in the summer, but it wants to be 70 in the winter. And it takes 40,000 plus BTUs to heat it to those temperatures and 20,000 for cooling. And your ducts have to be able to supply 962 cubic feet per minute of air movement in order to make the system work. So this is really key data that the load calculation produces, that your contractor should be able to explain to you as you go through this process. And if they don't have this, that they can supply you in writing, it's another kind of red flag that they haven't done diligence. All right, so design temperatures, it basically starts with recorded temperatures from your area. This is a graph that I find really helpful that comes from the Weather Service. We can give you the links to it. And this is showing that for Portland, for example, the dark blue lines, the recorded temperatures in 2025 for every day of the year, the historical highs and lows in red and blue, and then this kind of quote unquote normal, I don't know what's normal anymore, temperatures in gold here. And so that's kind of the background information. And then ASHRAE kind of analyze that, and they say, okay, for Portland, the 99th percentile. So that means only 1% of the days of the hours per year are going to be above 89, and only 1% of the hours per year are going to be below 24 degrees. So those are the design, what's called design temperatures. That means your system has to be able to keep your home cool at those temperatures, and maybe even a little bit of buffer. We'll talk about that with our panelists. And these temperatures can vary dramatically from place to place. So you can see in Denver, it gets very hot in the summer, so that the cooling design temperature is higher, and it also gets very cold in the winter, so very low design temperature for heating. And San Diego is a milder climate, so these temperatures are, you know, more in the medium area. Okay. The other important thing to understand about how heat pumps in homes work is that every home is going to be different. This is a very kind of simplified graphic to show what happens in a home as the temperatures go down. So over here at 65 degrees, your home basically needs no energy in order to maintain a 70-degree temperature inside. But as it gets colder, your house needs more energy in order to maintain that 70-degree temperature. And like I said, every house is going to be different. A well-insulated house is going to have a shallower curve because you need less energy as it gets colder, but every home needs more energy as the outdoor temperatures get colder. The other piece of information is that every heat pump, it has different ability to supply energy as the temperature gets colder outside. Because remember, you've got this box outside your home that's trying to suck energy out of the heat, suck heat out of the temperature, the cold air that's outside. So as it gets colder outside, it's harder for the heat pump to produce heat. So in general, every heat pump is going to produce less heat the colder it is outside. Now, new cold climate heat pumps might actually have a curve here instead of a straight line, but this is a simplified version of what we're trying to get at. But every system is going to have a different, line here in terms of how it performs with temperature. So the important thing to know is that what's called the balance point is where these things cross over. And what this is saying that in this case, whatever 17 degrees ish is the coldest outdoor temperature where this system can keep your home at 70 degrees. So that means that if it's below 17 degrees, this system's going to need some kind of backup heating in order to keep you comfortable, either heat strips, or maybe you've got a wood fireplace, or it could even be a gas furnace if things are really important and you need a lot of energy to keep you comfortable. So that's why this is really important to understand. And it's important to understand this kind of balance point idea relative to the heating design temperature. Because if your design temperature is 25 and your balance point is 17, that means that you're very rarely going to need backup heat. It's going to be, you're in the more record cold days where you're going to need backup heat. But if that same house has a different system and the balance point is higher temperature, like let's say it's 27 or 30 degrees, something like that, and your heating design temperature is 25, that means you're going to be using backup heating a lot. And if it's heat strips, which is electric resistance, you could be very unhappily surprised by what your electric bills look like in this situation. So this is why it's important to have this conversation with your contractor to understand what all this means, and to really ask maybe one of the most important temperature questions, which is, can the heat pump deliver the BTUs that are needed to keep your home comfortable at those design temperatures, which we all talked about. So we're going to talk more about this with the panelists, but this is kind of the crux move if you're trying to really understand how your system is going to work in those more extreme cases. There's a cooling version of this too. If you live in a hot climate, it would be how much energy your home needs in order to stay cool at those design temperatures. But it's the same, and there's no backup heating in this case. It means your house is going to get uncomfortably hot potentially if your system can't handle it. So that's why it's really important to feel confident about having this conversation with your contractor. And there's information that's going to come at you in terms of, like, the system capacity is usually measured in tons, and that can be converted to BTUs per hour. We have a handout on this, by the way, that we'll put a link in the chat. So all this is written down, so you don't need to take notes on all this. But this is this kind of system size and the nominal capacity, it's sometimes called, usually in tons. 3 tons is a very common system that'll provide nominally. That means 3,600 BTUs, usually at a pretty mild temperature. But that, capacity at lower temperatures will be different, which is why this kind of balance point thing that we just talked about is important to understand. There's also other ratings, which are called HSPF2 ratings. And by the way, not to be confused with HSPF without the 2 after it, because they changed this rating a few years ago. So make sure that it's HSPF2, so you're apples to apples. But it's basically the efficiency of your system, and a higher number is better. The minimum that you're going to see, because this is a federal standard, is 7.5 for, I think, most areas of the country. But it can go up to 13 for a really efficient system. So those more efficient systems are typically going to be more expensive, but a system that has a 10% higher HSPF2 rating is most likely going to result in 10% lower energy bills. That's a rough estimate, but that's essentially what this is saying. It's about efficiency. And then heat strips. If you do need heat strips, and it's not that these things are bad, it's just that you don't want them coming on too often, but you should know how big they are, because it can be pretty scary if you've got a 10 kilowatt heat strips and they all come on at once. That's like having 6 space heaters in your home turn on all at the same time. That's a lot of energy that you're paying for. So if you can avoid that, it's good, but you want to have that conversation. SEER is the rating for cooling. So just like HSPF2, it's essentially a efficiency rating, but in this case for cooling. The minimum standards in the country now are 14.3, but they can go really high, up to 25. So if you're in a hot area, you live in Arizona or even in Denver, which is one pretty hot area, you're going to want to see a pretty high SEER2 rating there. Here in Portland, where we don't have quite so extreme heat in the summer, this may be not quite as important, but again, it comes down to how much energy you're going to be using for cooling. And then finally, noise is something that, I don't know, some people are really tuned into this. We are in our home. Some people don't seem to be as sensitive to it. But if you have a heat pump right outside your bedroom window, for example, and you use air conditioning at night, you're going to hear that thing. And so you're going to want to know, how loud is it? And the lower this number is, the better. And keep in mind that, 10 decibels of increased decibels is essentially doubling the noisiness. So it's something to pay attention to if that's an issue for your home. All right. So just in kind of summary, you want to make sure they do a thorough evaluation. You want to have them explain this load calculation. You want them to give you these key specs, have them written down so you can provide apples to apples comparison from one system to the other. If it's a colder climate you live in, you want to dive into this heat strips conversation. What temperature do they turn on? Because your system is going to be built to have them turn on at a certain temperature. You should know what that temperature is, and you should feel comfortable that that's not too warm, so they're not going to be coming on all the time. And then you want to know about the price, of course. Incentives are a key piece of information that your contractor should be able to provide to you. If they don't, that's a red flag as well. And then, you want to know about warranties and service plans. We'll talk more about that with our panelists, but that's a good thing to know, because you're going to want to have someone come check it to make sure your system is working. So you should know up front, roughly how much that's going to cost. We have in our handout this kind of handy dandy checklist where you could compile all this information. Again, the links we'll put in the chat, but this could be a handy form to just compile that stuff. So if you're saying, talk to 3 contractors and you want to compare these systems one to the other, might make it easier than shuffling through a pile of papers. Okay, so in the end of the day, though, you still have to make this decision. And it's you've got a lot of information, but hopefully now you've asked the question, so you've got a sense of what system is going to provide the best performance. You've got, maybe you want to know which system you might prioritize, which one minimizes the need for backup heating, if that's a concern of yours. Keep in mind that a higher price might translate to lower energy bills, so you don't necessarily just want to go for the lowest price. And then, of course, there's this sort of intangible thing about which of these companies gave you the most confidence about doing a thorough job, about being able to explain this stuff to you well and provide you the kind of service that you're going to need potentially in the future. Okay, so let's dive into this with a panelist. I want to introduce each of them now. I'm going to start with Akanksha Mathur. She's from Elephant Energy in Los Angeles, and she's dedicated to home electrification. Elephant Energy is big on electrification and making it easier for homeowners to adopt heat pump technology. She focuses on homeowner education, incentive navigation, and simplifying the decision-making process. So we're going to ask her a lot of questions about decision-making at the end. And her work centers on creating a more informed and equitable path to decarbonizing homes. So really happy to have Akanksha with us. And then her colleague, Luke Govin from Elephant Energy in Denver is the same company, but much different climate in Denver. Luke has a really strong background in engineering and HVAC systems, and he's passionate about advancing clean energy solutions. In Denver, he has helped hundreds of customers transition from fossil fuel systems to efficient cold climate heat pumps. And drawing on his technical expertise and customer-focused approach, Luke works to make home electrification practical, reliable, and accessible. We love that here at Electrify Now. And then Aaron works with a local company here in Portland, Sunglow, one of our preferred partners, HVAC installers here. Aaron's got over 25 years of experience with HVAC and doing in-home consultations for residential heat pump projects. He's one of the guys that if all of these people are people we've chosen because they're the kind of contractors you want to be working with who are going to, be able to supply you with this information we've been talking about. He's BPI certified. He's got a NATE certification as well, which is, we can talk more about that as well, but that's another good thing to look for in terms of qualifications. That just means these guys have done their homework and passed a bunch of tests on all this stuff we are talking about. He's also a duct specialist, and his design process is centered on proper equipment sizing based on a really thorough evaluation of each home's insulation, construction, and duct systems. And he's really passionate about educating homeowners and helping them to understand the options they have to make sure they're choosing the right heat pump solution. So thank you, Akanksha and Luke and Aaron, for being with us today. And yeah, so let's dive into our questions. I covered a lot of information. We're going to maybe cover some of that same stuff again, but hopefully go into it with a little bit more detail with you folks and just help people to understand how to navigate this process. So
yeah, sounds great. Well, maybe we can start with just maybe a two-fer question and see who wants to take it first. But what are Brian talked a little bit about some of the critical information, but what are the critical questions and pieces of information that folks should be asking their contractor when getting a heat pump quote? Why don't we start with you, Luke, and then go to Akanksha and Aaron?
Yeah, thanks, Joe. Luke with Elephant Energy here. So overall, like the core information that you should be asking contractors is the specific model numbers for the equipment that they're going to be installing. Is very important to compare apples to apples between contractors. At least to start is making sure everyone is offering the same equipment. And if they're not, if there's deviations, figuring out why they're deciding to choose a different piece of equipment over another. So I think that's one of the more important pieces to ask for. The other one that might be obvious is just the general pricing, ensuring not only the total price of the project, but also any rebates that might apply for you.
Good call on that model numbers, so you know exactly what equipment that you're getting. Yeah. Akanksha, any thoughts to add to that on key questions or information?
Yeah, I'll just plug into what Luke mentioned, a little bit more specific. What we see here in Los Angeles is around pricing, because there is pricing and right sizing, because LA traditionally have a lot of 100-year-old, like those 1920s, 1930s home. It's what Brian was saying earlier. It's very important to make sure that your installer and contractor is actually asking the question on, do you know if you have double pane windows? Do you how's the insulation of the home? Is it really drafty? Is it really leaky? To make sure that they're gonna right size the equipment and also help you find a weatherization partner if they have one, just to make sure that the system that will be proposed works at its best efficiencies.
Aaron, you have any thoughts on that?
Hi, everyone. Aaron here with Sunglow. Yeah, I think another really helpful, insightful question to ask contractors is, What their methodology is to arrive at the recommendation that they've come to. I think it's critically important to recognize that not all contractors do proper sizing calculations and evaluate duct systems. And while these systems can work really well when installed properly, if contractors aren't doing heat load calculations and they're not inspecting the ductwork, even if they've arrived at the same final determination on equipment sizing, that does give some insight onto what their skill set is kind of under the hood, so to speak. And another really important question to ask, just the open-ended question of what sort of qualifications do the technicians have and what sort of training do they have? Because sizing really is the tip of the iceberg with a quality installation, and the quality of workmanship is paramount.
Yeah, that's a good point. Because I've heard this said before that you can have the system that's perfectly designed and spec'd and priced and everything, but then if it's not installed well, you're going to be you could potentially be very unhappy, and that's a little bit of a black box, isn't it? Because you're meeting with the contractor, who's the kind of technical consultant to figure out what should go into the home, but it's going to be someone else installing it, not that person that you're sitting there talking to. So yeah, Aaron, maybe just elaborate on that kind of the qualifications for the installer. Is there any in particular that you should be looking for in terms of a qualification for the people who are doing the installation?
Sure. So one universal qualification that applies throughout North America is the NATE certification program, and that stands for North American Technician Excellence. There are specific certifications within that program for heat pump installations. They separate service work from installs. In the state of Oregon, for example, Sunglow is registered with the state of Oregon and recognized as what they call an authorized apprenticeship training agent for the statewide journeyman HVAC program. That's a somewhat unique distinction that Sunglow has in the Portland area. Most residential contractors do not, they're not recognized by the state through their internal training practices. And unfortunately, in the state of Oregon, for example, the journeyman certification is optional, whereas what's much more common in many states is like electricians and plumbers need to have that journeyman status. So if you're working with a contractor who's registered as a NATE certified contractor and has journeyman certified technicians that are doing the installations, that's a really good indication that the technicians have a high skill set. The journeyman program, and if you're not aware of that, is essentially the equivalent of a 4-year bachelor's degree through college, but it's for the trades.
That's super helpful. Yeah.
And one other thing that you were saying, Aaron, and that Mark is asking, we're talking about heat load calcs. So Mark is asking, what are the acceptable ways of determining a heat load for a home? Maybe walk us through that. And Luke, why don't we start with you, and Akamshi, you can add anything.
Yeah, so the traditional and probably the most widespread way to appropriately calculate the heating and cooling loads for a home is using what's called a manual J heating and cooling load calculation. There's a lot of software now available out there that allows a contractor to run that report for your home. It's a process that you would probably want someone with more experience in entering those numbers to run for you, because it's a pretty open-ended calculation where if you put in wrong inputs, you get wrong outputs as well. But that's sort of the basis of a lot of the work that contractors do for sizing heat pumps, is a manual J heating and cooling load calculation. We also here at Elephant use actual gas usage information over the course of 12 months to calculate a heating load from your actual usage. So essentially adjusting for identifying what parts of the year that you are not using your furnace or your gas source, which is the summertime, identifying the baseline gas load, subtracting that from your wintertime gas load, and then comparing that to historical weather temperatures to calculate your actual used heating need for your home, as opposed to the more hypothetical or calculated from manual J. So either one of those two, a manual J or your actual utility usage information for your gas.
That's helpful.
Akanksha, I know, so where you are, it's really mostly cooling that people are probably concerned about. Is that true, first of all? And then, is there anything different about the process you would do in your area?
Brian, I believe that question was for me.
Yeah.
No, we do the same as mentioned. Like for LA, we focus more on the cooling load to make sure people are able to survive those 9,500 degree summer here sometimes and the heat waves. But rest of the process is very standard, very similar to what Luke mentioned.
So that brings the point, sorry, on the design temperatures, because I was a little surprised actually when I saw those ASHRAE numbers, and maybe if it feels, the ones that I was using, I think they were county based, which I was a little suspicious because it feels like you could have microclimates within a county. It could be quite different. But if I was okay, I live in Portland, so I was surprised the design temperature for cooling was 89 degrees, because it feels like we've been getting a lot of days over 100 degrees lately here. And so I guess my question is, do you guys, how do you build a little buffer into that, what ASHRAE says the design temperature should be, or you just design to that? Because it feels like, and if you don't, how do you describe to people what happens when it gets hotter than the design temperature or colder than the design temperature? Anybody want to tackle that? Long question.
Go for it.
Aaron, go for it.
Yeah, so one of the ways that I like to explain that, because it always is alarming when someone sees like an 89-degree design temperature, because obviously it gets warmer than that. If you were to be in your home and observe the temperature on the thermostat on a really warm day, if your AC wasn't running, if it got up to be, say, 105 degrees, which is not uncommon in the Portland area, the internal temperature in your home would never get to 105 degrees.
Okay.
And that has to do with the insulation in the home. Um, and it's important to take into account that the daily highs and lows and the thermal mass of the house are going to be somewhat of a buffer from the actual highest temperature that we'll see in any given day. So if you were to, watch outside temperature and inside temperature at your thermostat with no air conditioner running, it's going to be a pretty significant difference. So it really lies in like the thermal mass of the home and the daily highs and lows. And that's essentially what insulation is designed to do, is to the better your insulation is, the closer you're going to get to a stable, equal temperature throughout the entire day. And the poorer the insulation is, the more of a fluctuation you'll see on internal temperature.
So is that basically why you're saying that design temperature of 89 in Portland, you're pretty comfortable with that because of this thermal mass thing, even though the outside temperature might be well over 100 degrees?
Correct.
Okay.
Yeah.
I mean, Luke and Akanksha, do you have anything you want to jump in on that? Is that?
I can speak to you a little bit on at least for us here in Denver. I believe that Denver 99% point is somewhere around 0 degrees, maybe a bit warmer. It's around 5 degrees if you're in Boulder, getting closer to the foothills. And we will target a bit colder than that, even down at about -5 as our target temperature. We're trying to hit call it a 99.6% or better outdoor temperature. But to Aaron's point, um, there's a big lag between that outdoor temperature and your indoor temperature that can help kind of weather those events. And ultimately, we're talking about designing for a specific indoor temperature in your home. And if you are comfortable at 65 degrees, then all this kind of the math all changes for what might be your quote unquote right size for your home, which is what our goal is. So there's a lot of variability there with like comfort is subjective and like what are you comfortable with, but for the sake of comparing everything, we always, we use 70 degrees for heating, 74, 75 for cooling. But
Yeah, I guess that's an important point, isn't it? Because I think it's important for people to understand that if it gets colder, if your system is designed to heat your home to 70 degrees at, let's just say, 10 degrees of outdoor temperature, I'm making it up. And it gets down to 5, what's actually going to happen in your home? It's not like your home, it's not like your system fails. What happens is your temperature might go from 70 to 69 or 68 degrees. The heat pump isn't quite able to keep your home warm enough, right? So you might have to, on those days, you might either enlist backup heating or deal with a temperature that's a little bit less than what you would consider to be ideal. Is that an accurate way of thinking about it?
Yeah, I think so. Aaron, I see your hand up too, but yeah, yes, essentially, if you're comfortable with that operation, then that is okay.
Go ahead, Aaron.
I think another relevant consideration is that when we run these sizing calculations, if we have, for example, a heat loss number of 32,000 BTUs, we're either going to choose a 30,000 BTU heat pump or 36,000 BTU system. So they do come in incremental sizes of 6,000 BTUs. So in many cases, there's going to be some additional overage, if you will, from the size of the machine that we put in compared to the heat load calculation. So we will also evaluate how tight the numbers are and compare that to what people's expectations and desires are for indoor temperature. So that can sometimes sway the decision to increase or decrease the size of the machine based off of how much additional capacity is there in the system.
Right. So you could, in other words, you could be having a conversation with the client like, well, we could put a slightly larger system in. It's going to be more expensive. It will be more likely to keep you very comfortable at those lower temperatures if that's something you're worried about. Is that kind of what I'm hearing from you?
Yeah, it's not uncommon for me to meet someone who says, I don't want to ever experience a situation like I had 4 summers ago when we had that heat dome where it can't keep up, and I want to be comfortable year round no matter what. And if someone tells me that, I'm going to be erring on the side of ensuring that the system is larger than what I might otherwise choose. And sometimes people say, look, if it gets down to 17 degrees and holding for 4 days, which is kind of like our version of, an extreme cold snap. And they're comfortable with it dropping down to 62 degrees, and that's a decision that they're comfortable with, then we can support that as well.
Sure.
It just sort of makes it sound like it's really important as a customer to have that, to be transparent about that with your contractor, right? Because that can make a really big difference in terms of the system that they spec for you.
Correct.
Hey, just a follow-up question on that, because, you used to hear a lot, and maybe, Luke, this is a good question for you. You used to hear a lot that oversizing systems was bad because, then it would not operate very efficiently in those milder temperatures. But I'm also understanding that the inverters are getting so good now that they can ramp down so much that's less and less of a problem. I don't know. Did any of you have a comment on that?
I'll comment first. So all the cold climate heat pump rated systems and potentially even the standard climate systems, which I'm a bit less familiar with, not working in the warmer climates. But for cold climate systems, they have a variable speed compressor and they have fans with multiple fan stages inside your home, which means they can operate at a minimum capacity of say like 25 to 30%, which means they can meet those lower demands fairly easily if it's going to be not quite that cold outside or not that quite that hot outside too. So the oversizing, there's a limit to how much you can do that. So oversizing means you have a huge, 5-ton system and you only have 2 tons of need. That's going to cause problems in the what we call like the shoulder months when it's, spring and fall where it's not that cold or that hot, but you still want some heating and cooling. That's when the system is going to struggle and it'll turn on and off a lot and be less efficient and less comfortable. So that can still happen, but there is some flexibility where if you're oversized by, or quote unquote oversized by half a ton, the systems can normally handle that fairly well without any issues. It's once you start to really oversize that you see comfort issues and efficiency issues.
Gotcha.
Helpful. There's some good question or good comments from Ted, Tiffany, who we've had on the webinar before on some of these ASHRAE files. I encourage folks to look at the Q&A there. But just moving on, since we're getting a lot of good feedback and questions, there was a lot of good chatter about backup systems. And as you're getting heat pump quotes, how to consider keeping the backup system. Drew was saying that that crossover point that Brian was showing is not a big deal if you just keep your existing backup system, and that can provide all that backup heat you might need. But then Lisa was saying that in some areas like Maine, you can't get a rebate if you have a backup system. So maybe we could go one by one, and starting with Aaron, then Akanksha and Luke. Talk to us about how you factor in backup systems into heat pump quotes, and when it makes sense to keep somebody's existing system in place. Aaron,
Yeah, thank you. Yeah, so I think a really important factor when evaluating backup heating is looking at the heat load calculation and also evaluating the duct system. I do see some housing stock in Portland where the building insulation is really quite poor, and there literally is not a heat pump, a ducted heat pump that we can put in that's large enough because of the limitations of the duct system. Of course, making homes more energy efficient and adding insulation is really the best solution. But having backup in that situation, having like a backup gas furnace is going to be far less energy consuming than resistance electric heat if we can't get a large enough heat pump system in there. But it really just boils down to the heat load calculation and the size of the system that we can put in. Currently in our region, the Energy Trust of Oregon, who provides the rebates, they don't currently have a rebate if there's a backup gas system in place. They do support rebates if we have an all-electric system with backup electric heat strips.
So, Aaron, it's a good point. It's kind of like there's that period when homes were being built in probably between like 1920 or so and 1980, where they were forced air heating systems, but pretty small ducts in a lot of cases, and maybe not enough of them for what we would want nowadays. In the more modern homes, that's less of an issue, right? I don't know if 1980 is the right, you guys jump in, but that's what I've been hearing. The codes changed a lot and stuff like that in the 80s. But those older homes, if it's an older home with small ducts and poor insulation, that's a hard solve on those really cold days. So, we're not big fans of gas furnaces, period, but I do think it's worth just being truthful that there's those situations where, sometimes that might be the best cost-effective solution, unless you want to put the money into weatherization and duct improvements, which, in the long run would be a good investment, but that can be kind of shocking to upfront cost to people in a lot of ways.
Yeah, and in some situations, it's not terribly uncommon that I meet someone who values decarbonizing their home and getting off of natural gas as much as within reason, but maybe they have like a 5 to 10 year projection time in the home. So it might not make sense for them to invest in pumping insulation in the walls, because there are some houses here in Portland that have literally zero insulation in the walls. Insulating the crawl spaces and the attics are easier, but if someone moves into a home that's poorly insulated and they like to get a heat pump system, I still do feel like we're moving forward in a positive direction to get them off of the primary heat sources, natural gas, and put in like a dual fuel heat pump system. But and also the Energy Trust of Oregon is currently doing a pilot program that we were selected to install 50 heat pump systems in dual fuel applications, so they can evaluate whether or not that makes sense for them to incentivize in the future. We're pretty proud of being selected for that program as a sole contractor. But yeah, obviously, if someone's willing to invest into better insulating their home, that's going to eliminate or reduce the need for any sort of backup heat.
Luke or Akanksha, do you see that situation where you're just worried about the systems, the ducts or the insulation, making it just really hard to feel confident about the heat pump doing everything?
Yeah, I mean, I'll just jump in for LA, and all the time. Um, going back to as the heat pump awareness is rising, like I have been told a lot of contractors telling homeowners that you have such an old home, it's so leaky, there's no insulation, heat pump is not the option to go. Instead of saying that you should consider insulating, and then the efficiency and eventually the energy cost or the investment will actually give you returns. But yeah, it's more than we imagined. We
Do you
get that insulation again.
do you feel that the incentives for insulation are pretty decent in California? I don't know what they're like there.
Uh, so as of now, around the incentives, I would say they're most of the active incentives right now are from local utilities. There are no active, I would say, like when I'm talking specifically single homes, single family retrofits. There are no state or region level incentives as we speak. We had some until early 2026. They are on pause, potentially coming back. But yeah, there are incentives out there for insulation, and even changing windows and wall insulation, duct insulation, so everything.
Luke, what about Denver? I mean, you must have some old building stock there, but I would also maybe imagine that just because it's a cold climate, people kind of get the insulation is sort of a requirement. So I don't know, but do you run into that situation where you're just not confident that the home's ducts or their insulation levels are sufficient?
Yeah, it comes up primarily more for insulation levels than ductwork. I mean, there are a lot of really old ducts and some old Victorians in Denver and things like that. And you can, reseal them, re-insulate them as best you can. But what really comes up the most often is insulation. And so we notice there's a lot of brick homes with no wall insulation, which adds a huge amount to the heating and cooling loads of the home. So that comes up a fair amount. Unfortunately, when it comes to insulating your walls, it's a very expensive upgrade to your home. And so where we do recommend is like if your most homes in Colorado do have decent attic insulation, just by the nature of it being a colder climate. But if we do ever notice that it's very, very thin on the attic insulation, that's a recommendation to improve your heating and cooling needs by about 10% or more. If depending on how much of an upgrade it is. So we do see that. We do recommend that. I've kind of offered different options where I say, hey, here's your heat pump size based on the load I'm calculating right now with your existing attic insulation. I say it's a 4-ton system, but we can go down to a 3.5 or a 3-ton if you do this additional weatherization work and kind of let the customer sort of decide where they want to move forward overall.
Gotcha.
Helpful. Hey, Robert is asking, what do you think about heat pumps for individual rooms or areas? When do you think heat pumps for individual rooms or areas should be considered? And I'd love to hear that from each of you. Maybe, and we can bring it into larger conversation. Brian and I talk a lot about ductless versus ducted, and we talked a little bit about the backup electric resistance strip heat, which on a ducted system you can have that, but ductless don't have the backup electric resistance. So talk to us about, do you lean one way or another, ducted versus ductless? Does it depend on the home layout? How do you navigate that in your heat pump quotes? Aaron, why don't we start with you?
There is some subjectivity to it with people's preferences. I personally have the opinion that a large array of multi-zone systems is not always in our client's best interest when we look at long-term maintenance and eventual breakdown. The more pieces of equipment that they have, the more things will eventually fail. So I do think that's important to keep into the conversation. Sometimes there's housing infrastructure that doesn't really support. In the Pacific Northwest, we have a fair amount of houses that just have a bunch of cadet heaters everywhere, and no ductwork. So that's going to be a practical time to implement a ductless products. There's also some houses that have really, really horrible ductwork that just needs to be completely ripped out and entirely redone. So, there's a myriad of factors that influence which direction we'll go with the homeowner. And really, it's about collaborating with homeowners and understanding what their needs and preferences are, and then just having a reality check on the existing infrastructure in their homes.
That sounds good. And Luke and Akanksha, is there any thoughts in your mind? Luke, I know in other webinars we've had with Health and Energy, you often don't install strip heat, backup electric resistance heat. Correct me if I'm wrong there, but do ductless systems help you avoid that, or are you not installing strip heat also with ducted systems?
Strip heats for ducted system are kind of as needed for the home based on how we're sizing the heat pump and what we see for their heating needs. I'd say for about 90% of the designs that I work on, we determine like if we size the heat pump appropriately, you don't need backup, whether that's electric resistance heat or a furnace backup. For ductless, there's less flexibility with what you can do for backup because you have these individual heads that are going to each room. They don't come with electric backup heat sort of integrated with them. And so backup heat then becomes, if you have a wood burning fireplace, or you have space heaters in a room, or even a separate electric baseboard for a room, that would be an option. But in general, when I'm sizing for ductless, we're trying to get everything to be covered by the heat pump rather than having backup.
So, Luke, on the ducted systems with no heat strips, what happens during defrost cycles? I mean, are they blowing cold air into the home, or is that an old thing that's been solved with newer technology, or what happens in defrost?
So it wouldn't be necessarily blowing cold air. It's more, I'd say probably lukewarm air or me warm air to make a joke about my name. So that's what will happen during the defrost cycles, but it won't be like fully air conditioning your space.
Gotcha.
Right, great. One interesting question from Diane. Brian was talking about um, the higher equipment is rated for efficiency, whether that's HSPF2 or SEER, the less your utilities are going to be in general going forward because it'll be a more efficient equipment. But those tend to cost a little bit more money. So Diane is wondering, is there a sweet spot on upfront cost versus the higher efficiency rated equipment? How do you help folks navigate that? They could spend a little bit more now to save more later, or spend less now but pay more later. Akanksha, do you want to start us off there?
Yes. I mean, again, going back to like in Los Angeles County or surrounding Southern California area, we people are really price sensitive, and electricity rates are really high. So the repeat question that we keep getting is like, am I going to reduce my energy cost over time? And so far, we give both the options to the homeowners, right? Going back to what I was saying earlier, in the end, the decision needs to be made based on what homeowner priorities are. So both the options are given. More often, we see homeowners going for a higher efficiency system, and because of two reasons. One, longer term, obviously reduce energy pricing, so reduce energy consumption, hence the utility cost. And along with that, even the incentives, a lot of incentives like DWP incentives and so on, they are tiered. So higher efficiency would get higher incentive. So overall, a lot of times, like economics just works out that way, that it's worth those few hundred or 1,000 or whatever dollars when you're going for a higher efficiency system.
That's interesting. You see folks choosing the more efficient equipment. Aaron and Luke, in your markets, do you give them the two choices, the more efficient equipment versus maybe the little bit less efficient equipment? And do you see folks going for that more efficient equipment?
Yeah, so we do offer kind of whenever we can, a good, better, best sort of tiering with the equipment types. And with their associated efficiencies. Though I'll say we're usually focused on hitting the capacities and then offering different options from different manufacturers to meet those capacities. And depending on the specific frame size of the specific manufacturers, the efficiencies can change a bit. Where one manufacturer may generally have higher efficiencies, but might not have higher efficiencies at a specific frame size that we're looking at. So our focus is primarily around quality, brand quality, and reliability, serviceability, but efficiency does come up as we get to our options, and then we say, oh, this is 10% more efficient here. Therefore, if your bills are expected to be X dollars, they'll be Y dollars if you switch from one to the other. So it tends to be a conversation that happens after a conversation about reliability.
Aaron, what do you see?
Well, one thing that's interesting is based on the energy efficiency of various homes. For example, a poorly insulated home is going to need a lot more heating, whereas a really well-insulated home in our region has a pretty, what I call a balanced load between the summer and the winter demands. So not only, as you had covered before, the term HSPF2, there's also SEER2, SEER2, and EER2. And so if we have a house with less insulation, the HSPF, the winter efficiency, is going to be far more important because it's going to be more active. But if you have a really well-insulated home, it's important to take more into account for not just the HSPF, but the SEER rating as well. And throughout various manufacturers and different model numbers, you're going to see in some cases, the HSPF2 number is going to be higher in one brand or one particular model. And then you get to a cold climate version versus a standard climate version. And with these inverter technology systems, there are some products that aren't technically rated as a cold climate heat pump that still have really strong winter numbers, and will be sufficient for the heating capacity, but will be far more energy efficient for cooling. So it's really a conversation where having your contractor provide what's called an AHRI certificate, which is a certificate of performance. That sheet is kind of like the sticker on the car that shows your mileage ratings, the overall horsepower of the vehicle, so to speak. But with any particular model that's being offered by a contractor, they should be providing you a certificate of performance where all of those numbers are clearly listed. And oh, there it is.
Yeah, this is what that
So
looks
that
like.
decision can be made on a case-by-case basis based off of people's priorities.
So yeah, I was going to ask you guys about that because this is something that, yeah, you can ask your contractor to give you this, and it's a little bit of a seal of approval type of thing, isn't it? I mean, do you normally supply this, Aaron?
I do.
Yeah. What do you guys? I mean, Akanksha and Luke, do you find this helpful? This certificate?
Yeah, I mean, it's part of the package of all the documentation that would go to a homeowner. And again, coming back to the incentives, most of the incentives here in Southern California right now do need a AHRI certificate to be submitted for
Gotcha.
getting the funds.
Gotcha.
Great.
Hey, I wanted to ask you a little bit, you guys, a little bit about noise. You know, I mentioned that in the intro. Are you seeing that? Are you seeing big? Because we already talked about, so the different manufacturers and the different model numbers can have different HSPF2 and SEER ratings, but they can also have different noise levels, I imagine. Do you see big variation from noise from model to model or manufacturer to manufacturer? Or are people getting pretty good about getting quieter and quieter?
I'll speak to, generally speaking, we find Mitsubishi is the quietest. They're all fairly quiet, especially compared to traditional systems. If you have a heat pump with a variable speed compressor inside, the outdoor unit's going to be substantially quieter than a typical AC, like in the range of mid 50s to mid 60s decibels versus 70s to 80s for an AC. Because of how sound power works, that means it'll sound like half as loud as a traditional AC. specifically Mitsubishi is we've seen that has the quietest performance specs, but again, it depends on the specific frame size and all that.
Mhm.
Aaron, anything to add there?
Yeah, I would say, with inverter technology, it's true that there can be some variation on, as we talk about frame size, that has to do with the BTU capacity of the machine. We do Mitsubishi, we also do Carrier, and they're all getting to a level that's so close that there's not like when you compare a traditional air conditioner that's, 72 to 75 decibels, and then you get all the way down to two different model numbers that might be rated at 52 or 54 decibels. The impact of sound reduction for either one of those lower 50 dB systems is going to be so substantially quieter than a traditional AC that I kind of feel like it becomes somewhat irrelevant between different products.
Gotcha.
Yeah. And it's not just outdoor units, right? The indoor units are getting quieter too. We had a system installed 2 years ago, and it's just like, is it on? It's just so quiet,
Yeah,
It's
well,
on.
that depends on the type of system. So there are some inverter systems where the indoor variable speed fan will proportionately ramp up and down relative to whatever the compressor is doing outside. There are some other systems where there'll be uh, a more or less constant volume of airflow. And depending on how the ductwork is installed and where the machine is located, what I tell people all the time is volume of airflow doesn't have a brand or age. It's just a specific, sound turbulence and that's passing through the system. So if you're moving a similar amount of air, you're likely going to have a similar sound level. But with these variable speed fans, ramping airflow up and down, that's a key feature. But when any system is going to be running at 100% of its capacity, there's still going to be, a fair amount of sound coming through there. But we can do like sound attenuation in the ductwork or redesign of some systems to, strategize quieting the system down.
Great. I see Beverly has a comment in the chat. Beverly, we are not going to get into portable heat pumps. We have a good webinar on that hopefully we can put it in the chat for you. We've done some deep dives on those. And Ted has some other great ideas on sound mitigation. But we are coming up on time here. And Brian, we've got a good, I think, final question. Let me know what you think. We've been talking about all this information, but, we don't want to overload people. And in the end, they're going to have to make a final decision. So we wanted to maybe turn it over to each of you and say, you know, how we've talked about a lot of the information that people will get and what they should consider, but how do they make that step and make the final decision? Any final advice?
Yeah, any advice you have for how to parse through all this, even the good, better, best thing, it's kind of like, wow, which one? Yeah, how do you advise your customers on that front? Akanksha, do you want to start us off?
Yeah, sure. I'll just start by saying, one of the things, the way I would put it, depending on homeowner to homeowner, but the idea is everyone should not have to spend hours and hours understanding the technical part of, unless obviously there are people who want to understand. But to put it really simply, right, identify what your priorities are, what your pain points are, and drafting the questions to the installers around that. Like if you are budget sensitive, then try to understand based on all that we have heard on the panel is what's going to give the best bang for my buck, right? In terms of I'm getting the efficiency. Again, Los Angeles is a milder climate, so we don't need to go. If your home is well insulated, the efficiency could be somewhere where you could compromise a little bit. If your home is really leaky, but then again, you're not having those 20 or 10 or even 0 degrees of winter, but we are having 100 degrees summer. So pricing. Do keep eyes open or ask around incentives, right? Which ones can be stackable? And one topic that I believe didn't come up was financing. We see a lot of there are a lot of financing options out there, which helps people just reduce that one big investment to smaller. And there is up to 0% financing options available out there for eligible homeowners. So yeah, so ask about what equipment find that right balance that would work for you between the efficiency and the pricing, putting the incentives and financing together.
Thank you. Hey, I just one follow-up on the financing thing. I have heard from some people that you got to be a little bit careful that some of those financing plans that where they have zero upfront or something, they basically built some costs into the quote. They've inflated the quote to pay for the 0% financing. I mean, I'm not accusing you guys of being shady, but I'm just wondering, like, is that a thing? Is that something people should be worried about or ask questions about? It sounds like you were saying the 0% financing was income qualified, maybe from some third party, but is that something people should be aware of? Any of you have comments on that?
If I may jump in, because again, I got those comments from homeowners during tech clean when, Q4 or Q3 last year, when here in Southern California, because of Go Zero, because of tech clean, because of DWP, homeowners were able to get their water heaters at no cost. And we installed a couple water heaters where homeowners out of pocket costs ended up almost $0, right? It's unbelievable. But then, the answer to your question is yes. Unfortunately, I have heard homeowners saying that they felt that installers were jacking up their prices just because there was all these incentives available. And I think it goes back to asking, can you tell me what the pricing or the code that is being shared, what all does it include, right? Most of the installers should be able to break it down into what is the equipment, labor, permitting, inspection, not at very detailed line level, but just make sure what all is included in the pricing that they are putting in.
I'll go ahead and take the bait and answer that question more directly about financing. I think it's important to consider that if we go to the grocery store to buy our weekly groceries, we're not going to be able to ask our local grocer for a cash discount as opposed to using a credit card or a debit card. So there are some fees that are just assumed to be a cost of doing business. Now, there are some contractors out there that will take whatever financing they're offering and what we would refer to as what's called a dealer fee and just apply that dealer fee directly to that project. And technically that's not legal, but there are contractors who do that. I will tell you at Sunglow, we don't charge anyone for additional financing. However, we're quite selective on what financing offers we do provide that are done through us. We do work with various manufacturers, and one of the benefits of being a premier dealer through the manufacturers that we work with is that they have negotiated terms with different financing organizations where they do what's called a buy down rate for their selected and preferred contractors. So I think the assumption would be if you're going to use a credit card, whatever the organization is that's accepting that card is probably going to have to incur a 2% or maybe even a 3% processing fee. And if a contractor incurs a similar fee for offering financing rather than just taking someone's credit card, but it can provide the homeowner with a better financing rate that's in their better interest, there's really nothing wrong with that. I think one question you had for me, Brian, over the phone was whether or not, to ask maybe if people can offer a cash discount. And the contractors, generally speaking, the contractors that are charging homeowners for the service of providing financing will also provide a cash discount if someone doesn't offer financing. And that's a pretty good indication that a contractor is actively charging a homeowner more money to offer financing if they're willing to provide a cash discount. So like with Sunglow, for example, it doesn't matter if someone uses a personal check, a credit card, or uses one of our financing offers, the price is the same. And they're all very modest and acceptable fees that are just assumed as a process of doing business.
Yeah, that's super helpful.
Luke, any final thoughts from you on either the financing question or just how to make that final decision?
Yeah, on the financing piece, I echoing what Aaron said, like there are dealer fees that can be associated with the specific financing package that you're looking at, and yes, legally we cannot. That is just a fee that we have to incur on our side, which is that's totally okay and kind of part of offering financing. In terms of like final thoughts for comparing quotes, I'd say keep it. I always recommend even to folks that I'm talking to who are looking at my quote and then also might consider other quotes, like get at least 2 to 3 quotes to compare, maybe for your own sanity and as a gut check, just to make sure, you're feeling right about who you're choosing. I'd say you can get 10 quotes. You can get 20 quotes if you want to, but there gets a point where it's a bit too much like information to be parsing between all these folks, and keeping it maybe focused on a set of 2 or 3 at a time. And if you work in a set of 2 or 3 and you decide, I wasn't really quite sure, then you can kind of move on next. But like try to keep it a bit more focused on contractors that you do get a good sense from, that you can ask these technical questions to, and they give you answers quickly. They respond quickly. They don't take, say, 2 weeks to get back to you on sort of system design, especially when talking about a cold climate heat pump where system design is especially important, and it's not just a swapping out the box like it has been in the past.
Great.
Great. That's super helpful.
Well, thanks everybody. We've gone a little bit over, but yeah, appreciate all your time and your expertise. Yeah, really appreciate having you on.
Yeah, thank you very, very much to all our panelists, and thank you all for tuning in today, and good luck with all your electrification projects. If you have any other questions that we can help you with, feel free to reach out to Joe or I. Will either answer your question or find someone who can. And yeah, hope to see you at one of our upcoming webinars in the future.
Thanks so much.